Hello, good day, welcome back once again. Today this is our second class of Laplace transform of some given functions. Here we have the following function of t e to the power of at. A here is a constant. Right over here we're going to find the Laplace transform of this function. Well, yes, that is an exponential function, right? Okay, now with the definition of the Laplace transform, we all know the Laplace transform of a function of t. This is given as the integral from 0 to infinity of f of t multiplied by e to the power of negative st dt. Right? Now, let us find the Laplace transform of this function right over here. So we have the Laplace transform of e to the power of at. This is equal to the integral from 0 to infinity e to the power of at multiplied by e to the power of negative st dt, right? Now, making use of some basic algebraic properties, when we have a to the power of b multiplied by a to the power of c, since we have equal bases, so this is same as a to the power of b plus c, right? So here we get the Laplace transform of e to the power of at. This is equal to the integral from 0 to infinity e raised to the power of at minus st, right? You know we are adding the powers here. That is at plus negative st. This simplifies to at minus st, right? So here we have dt. Now from here, we're going to factor out negative t from the power of this e here, and we get the integral from 0 to infinity e to the power of negative t. Then in the bracket right over here, we're going to have s minus a, right? Then dt. Now check it out. Negative t times negative t times s will give us negative st, and negative t times negative a will give us positive at. Okay, now from here we can make a substitution. We're going to let t into bracket s minus a equals y. When we divide both sides by s minus a, we get t is equal to y over s minus a, right? So now differentiating both sides, we get dt is equal to dy over s minus a, right? Now what happens to the limit of integration? You know, when t is approaching 0 right over here, y is also approaching 0. And when t is approaching infinity, y is also approaching infinity. Here we get the Laplace transform of e to the power of at. This is equal to, now we have the integral from 0 to infinity e to the power of negative y. That's what we have there. Then times dt will be dy all over s minus a. Now from here we get the Laplace transform of e to the power of at. This is equal to, here we have 1 over s minus a outside, right? Then we have the integral from 0 to infinity e to the power of negative y dy. And we know what this integral is. The integral of e to the power of negative y is negative e to the power of negative y, right? So we have 1 over s minus a multiplied by negative e raised by negative y. And don't forget our limit of integration from 0 to infinity, right? So from here we get the Laplace transform of e to the power of at. This is equal to 1 over s minus a. Now, when you put the upper limit, we get negative e to the power of negative infinity, and that is 0 minus, in brackets, negative e raised by 0, right? So from here we get 1 over s minus a multiplied by, you know, here this will become 0 plus, because minus times minus is plus, then e to the power of 0 is 1, right? So from here we get the Laplace transform of e to the power of at. This is exactly equal to 1 over s minus a. Amazing. Okay, now what if we are given the following function of s, the following function of t, to find the Laplace transform of what are we going to use here? So let's say we're asked to find the Laplace transform of e to the power of, let's say, 5t, right? And again, we are given another function f of t equals e to the power of negative 2t. Now, for the first one right over here, the Laplace transform of e to the power of 5t, this is what I actually mean. This is going to be equal to, right over here, a is going to be equal to 5, right? And when you put a equal to 5, we get 1 over s minus 5. And this is the right answer. And to the other side, the Laplace transform of e to the power of negative 2t, this is going to be 1 over here, a is going to be equal to negative 2, and that will be s minus negative 2. And this simplifies to 1 over s plus 2. And this is the right answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye. See you in the next class.